Hi everybody. Binary search is an efficient search algorithm that can quickly find an item in a sorted list of items. In this video, we will discuss the basics of binary search, including how it works, time complexity, and how to implement it in C code. By the end of this video, you should have a solid understanding of binary search and how to use it in your own projects. Let's take a look at binary search and see how it works. To illustrate this method, we will use sorted array of 15 integers and find if a target value t exists in the array. The first step in binary search is to determine if t exists in this array. It must be between the first and the last element. To do this, we can express the idea by defining two integers variables called L and R for left and right respectively. The position of L will be the first cell of the array, and the position of R will be the last cell in the array. The next step would be to check the number that's in the middle of L and R, cell 7. T is smaller than the middle cell, then the search will be restricted to the first part of the array. So we move our right pointer R over this middle cell to the left. We repeat this procedure to narrow down the search region more and more. We check with the middle cell of L and R. T is greater than cell 3, so L is positioned at cell 4. T is smaller than cell 5, so R is positioned at cell 4. T is larger than cell 4, so L is positioned at cell 5. Now we can stop the search since R has become smaller than L. The target T is not found. Let's take another example. Now we are looking for the target's value 62. We set L at the first position and R at the last position. 62 is between L and R. We check with the middle cell, cell 7. Since T is larger than cell 7, we move L to position 8. We check with the middle cell, cell 11. Since T is smaller than cell 11, we move R to position 10. We check with the middle cell, cell 9. T is found at cell 9. So the search ends. We will now look for the complexity of the binary search. At each iteration, the size of the array is divided by 2. So we are interested in how many times we do this division of the size of the array. The first division gives n by 2. The second n by 2 squared, then n by 2 to the power of 3, until we have an array of size 1. To find the number of divisions needed to obtain an array of size 1, we have to solve the equation n by 2 to the power x equal 1. If we apply the log function to this equation, we get log 2 of n equal log 2 of 2 to the power of x. Therefore, the equation has a solution log 2 of n equal x. X is the number of times n must be divided by 2 to obtain 1. We can therefore conclude that the complexity of the binary search is O log of n, where n is the number of elements in the array. Let's now write the program. We have the same array as before. We are going to write a recursive function. You will find the iterative version in the description of the video. This function will have 4 parameters: the target value, the array, and the first and last indices of the array. This will be used to initialize left and right L and R. At the beginning, if L less or equal L, I assign to mid L plus R div 2. If T less than R of mid, I return binary search TRL mid minus 1. Else, if T greater than R of mid, I return binary search TR mid plus 1 R. Else, the target is found, I return mid. Else, if L greater than R, I return minus 1. Now we are going to run our program and search for a value that doesn't exist. We obtain minus 1. Change the value 62 I run the program and we get 9. 9 is the position of 62 in the array.
Merci de votre attention et à très bientôt.